Good evening, my dear students. Welcome to IMS Gate Academy. Hi, I am Vipin Mishra and you are watching the PYQ series of IMS Gate Academy, in which I am going to discuss the PYQs of power system and power electronics for the year 2018. So we started from 2013, 2023 and we have reached up till 2018. All other lectures are available in the playlist. You can go and watch them. PYQs plays a very important role, because somehow you will get the same flavor of questions in the upcoming GATE exam. So practice PYQ as much as you can, and that's why, because IMS GATE Academy really cares for you, and that's why we are coming with this series. So let's get started with the questions of 2018. So this is the first question that I have, and it is from load flow analysis of power system, and it's a very important topic. And what has been said in this question is a 1000 cross 1000 bus admittance matrix for an electric power system has 8000 non-zero element. Okay, the minimum number of branches, that is the transmission line and transformer in this system, will be how much? So how many minimum of number of transmission lines are there? That's what we have to calculate, and we have been given the order of the matrix and how many non-zero elements are there, that is also given. So I will tell you two approaches for solving this numerical. Let us go with the conventional approach. So we have to find out the number of transmission line. So the number of transmission line, what is the formula that we have? So number of transmission lines, if we write them by T, this is equals to n square 1 minus x minus n by 2, where n is the order of the matrix, x is the sparsity, okay, and this is how you can calculate it. Now we have been given the total number of non-zero elements. Okay, so what are the total number of elements? So if we calculate total number of elements, so how many total number of elements will be there? Just see, if we have 2 cross 2 matrix, how many number of elements are there? 4. 3 cross 3 matrix, 9. Means whatever is the order of the matrix, just square it and you will get the total number of elements. That's what we will do here as well. So the order of matrix is 1000 cross 1000. So 1000 square will be the number of elements. Now out of which, so this is how we have calculated total number of elements. Now we need to get the sparsity. So sparsity, that is x, has a formula that it is equals to number of zero elements. So number of zero elements divided by the total number of elements. So how many total number of elements? We have already calculated total number of elements. So just see, number of zero element, we have total number of element which are equals to 1000 square minus, out of which there are 8000 non-zero elements. So if you will subtract non-zero elements from total element, you will get the number of zero elements, okay, in the matrix, divided by total number of element, which is 1000 square. On solving, you will get 0.992. So this is how you will calculate x. Now come back in the formula once again, and number of transmission line, this will be order of matrix is 1000. So 1000 square 1 minus 0.992, the sparsity minus n is 1000 again, divided by 2. So what you will get? This will give you 8000 minus 1000 divided by 2, 7000 by 2, that is 3500. So number of transmission lines are 3500. This is the conventional way of solving this numerical. This is how you could have solved this numerical by the conventional approach. Now we have a short trick as well, okay, and what is that short trick? Let me tell you. So the short trick is, if suppose number of non-zero elements are given, or we have to find number of non-zero elements, so the number of non-zero elements, okay, the number of non-zero elements, this is equals to number of diagonal element, this is equals to number of diagonal elements plus 2 into number of transmission lines. This is the shortcut formula that you can use for this numerical. So now put the values and what we will get, just see. So number of non-zero elements are given to us 8000, isn't it? Number of diagonal elements, if we have 2 cross 2 matrix, number of diagonal element will be 2. 3 cross 3 matrix, number of diagonal element will be 3. Like the same way, We have 1000 cross 1000 matrix, so the number of diagonal element will be 1000 plus 2 into number of transmission lines. Let me write it T. So from here what you will get as T, again it will be 3500. So it took a lot of time from here, but it took only a while to solve this numerical with this formula. Okay, so this is how there are two approaches available for this numerical. You can adopt any one, and this type of question, it has a huge probability that it can be the part of 2024 GATE exam, because last time this type of question was asked was in the year 2018, and since then we have no question from this particular analysis. So it has a huge probability that there will be a question in the paper 2024 from the same topic, same analysis. Okay, so did you like the approach we have solved this numerical? I think you have. Okay, so if you want to experience the same teaching and learning methodology, you can join our live online program if you are preparing for GATE 25 and 26, in which you will get exciting number of offers. We are offering 800 plus hours of live classes with live interaction, and you will be getting tremendous content as well, in which we will be offering you theory books for each subject, exercise book that contains 3000 plus 4000 plus questions, alongside with the GQB that contains all the PYQs, and 130 plus online test which contains 3000 questions. So if you will practice these 7000 questions, nobody can stop you becoming a GATE topper. Alongside that, we are also offering 12 personalized mentorship session, in which you can talk to us and you can strategize your preparation and doubts. So if you are really interested, you can call on this number. And in the meanwhile, do not forget to join our Telegram channel, which is free of cost. The link is here, and the link is also given in the description box. So you can click and join the Telegram channel, in which you will get the schedule of all the upcoming YouTube sessions. You will get the important updates related to seminar, webinar and career guidance program. You will get all the PSUs and government job notification as well. Alongside that, you will get a quiz activity available here free of cost as well. So join our Telegram channel and enjoy all those things. Now coming back to the next question, just see, this is the second question that we have, in which what has been given to us is the positive, negative and zero sequence impedances of 125 MVA 3-phase 15.5 kV star grounded 50 Hz generators are given to us. So let me write those values. Positive sequence impedance, this is J 0.1 per unit. Negative sequence impedance, this is J 0.05 per unit. And zero sequence impedance, this is J 0.01. Alongside that, we have these impedances are given. The machine is unloaded and working at rated terminal voltage. If the grounding impedance of the generator is J 0.01, so the grounding impedance is also given. Okay, so Z of N, the grounding impedance, this is J 0.01 per unit. Then the magnitude of fault current for a B phase to ground fault in kiloampere will be. So there are three phases, A, B, C or R, Y, B. We have to find out the fault current from B phase to the ground, means we are interested in line, any of the line to ground fault. So what type of fault we have? You have to recognize that first of all. So it is an LG fault. So what is the formula of fault current in LG fault? This is equals to 3E upon Z1, the positive sequence impedance, Z2 plus Z0 plus 3Zn. So just put the values, 3 into 1, E might be taken as 1 always, Z1 is 0.1 plus Z2 is 0.05 plus 0.01 plus 3 times 0.01. So on solving it, what you will get? We have to solve this expression, and on solving you will get 19.53 as 15.78 as the value of the fault current, and this will be in per unit. But the answer that we have to give in kiloampere. Okay. So whenever you are engaged in solving a numerical where per unit quantities are involved, always looks for whether you have to answer in per unit or in other quantities. Okay, like kilovolt, kilovolt, kiloampere and ohms, like that. Okay, so we have to answer in kiloampere, not in per unit. So we have to convert this quantity into kilo ampere current. So the same current, if we calculate in kilo ampere, this will be equals to line to ground fault current in per unit multiplied by the base current. Okay, so this is what 15.78, and you know the formula, S is equals to root 3 V into I. So what will be I? S upon root 3 V. The same way we have to apply here the same formula. So S is basically given 125 MVA, okay, and upon root 3 voltage is given 15.5 kilovolt. Okay, so when you will put the value and you will solve it, you will get the final answer as 73.5 kilo ampere. So this is the small exercise that you have to do here. Okay, the confusion is so many students, they have answered in per unit, but you have to answer in kilo ampere, and you have to recognize what type of fault it is, which we have recognized by going through the question. Okay, so just go with the flow of the question and you will recognize what exactly the question is asking for. You will reach to the formula and then you will be able to solve the question very easily. Okay, so every year from 2023 to 2018 we have a question from fault analysis. Not a single year we have seen in which there was no question from fault analysis. So you can see the importance of fault analysis. It is very, very important. Okay, in the 2024, in the 24 paper, you will also see a question from fault analysis. So be be prepared for that. Okay, now second question from fault analysis. What this says is, the series impedance matrix of a short three-phase transmission line in phase coordinates is given like this. If the positive sequence impedance is 1 plus J10 and the zero sequence impedance is 4 plus J31 ohm, then the imaginary part of Zm, the mutual impedance, will be what? Okay. So for a transmission line, we have self impedance of a line and there is a mutual impedances between the line. So this has been given. The matrix is given in the form of self and mutual impedance. If we convert this matrix into the zero, positive and negative sequence component, what are the values that we have? So the zero sequence component Z0, this is having the value Zs plus 2 Zm, and how much is the value given to us for zero sequence? It is 4 plus J31. The positive sequence and the negative sequence impedances are equal to each other and they are Zs minus Zm. And how much is the value of positive sequence impedance? It is 1 plus J10. So just put the value 1 plus J10. Now you require to solve for Zm. Okay, so what you will do here? Just subtract these equations. Okay, just subtract this equation. So this will get cancelled and you will get 3 Zm. This is equals to 4 minus 1 3. 31 minus 10 will be 21. So Zm will be simply 1 plus J7. Then what will be the imaginary part of Zm? So the imaginary part of Zm is basically what? It is 7 here. Okay, now that's your answer. That is your answer. The imaginary part of Zm is 7. So this is small exercise you have to do. So you could have solved this question if you know what are the values of positive, negative and zero sequence impedance of a transmission line. Okay, so positive and negative sequence impedance, they are Zs minus Zm, they are equal to each other, and zero sequence impedance is the highest and which is Zs plus 2 Zm. So for a transmission line we have Z0 greater than Z1 equals to Z2. Okay, remember this fact. So this is how you could have solved this question as well. Moving towards the next question. See this one. Again, this is from fault analysis. So it's like a jackpot. If your fault analysis part is very good, you have 3 questions coming from fault analysis carrying total 4 marks. So it's like a jackpot, isn't it? What this question is saying is, the positive, negative, zero sequence impedances of a 3-phase generator are Z1, Z2 and Z0. Fine. For a line-to-line fault with fault impedance ZF, what type of fault we have? We have line-to-line fault. Okay, line-to-line fault, double L fault. The fault current is IF1 equals to KF. If IF is the fault current with zero fault impedance, the relation between ZF and K will be what? So what are they saying? It's a LG fault. Sorry, it's a line to line fault. So for a line to line fault, what is the fault current? For a line to line fault, the fault current is basically root 3 E upon Z1 plus Z2 plus ZF, isn't it? Now when we are not considering ZF, means when ZF is 0, at that time they are calling the fault current to be IF, and that fault current will be equals to root 3 E upon Z1 plus Z2. As per the formula, there will not be any ZF. Okay. Now when we are considering ZF, means ZF is not 0, at that time they are calling the fault current to be IF1, and the value of fault current will be the same, whatever is the formula, root 3 upon Z1 plus Z2 plus ZF, isn't it? Now they have given a relation between the two cases, that I of F1 is basically equals to K of IF. So what are the values? Just put here root 3 upon Z1 plus Z2 plus ZF, and K times what is IF? Root 3 E upon Z1 plus Z2. So just see, this will be cancelled, and when you will solve for ZF, what you will get? You will get 1 minus K over K times Z1 plus Z2, which is given in the option number A. So A will be the correct option. So is there any problem in solving this question? This question was like a treat, isn't it? Just see. So how easily we have solved this question. Only one thing you should know, the formula of line to line fault. Okay. So there were two questions from directly from fault, one was indirectly from fault, that we have solved. So total 4 marks of questions were only from fault analysis. Okay. So if your fault analysis part is very good, you could have scored more marks in GATE exam. Yes or no? Yes. Okay. So moving towards the next question. Now this question seems to be the very difficult one, but see how easy it is. Okay. You will feel that this question is in fact a very easy one. So what has been given here is, consider the 2-bus power system network with given loads as shown in figure. So we have 2-bus power system. This is bus number 1, this is bus number 2. Okay, and both the buses are having generators and loads. Fine. All the values are shown in figure are in per unit. The reactive power supplied by generator G1 and G2 are Qg1, Qg2. The per unit values of Qg1, Qg2 and line reactive power loss Q loss will be respectively what you have to calculate. Okay. So it seems to be a very difficult one, but in fact it is very easy. Just go with the flow of the question and you will see, you will decode what has been given and what we have to find. Okay. So we have to calculate Qg1, Qg2 and Q loss. Now just see, if you see at bus 1, so at bus 1 there is generator 1, okay, at bus 2 there is generator 2. Now just see at generator at load bus 2. At bus 2 the active power demand is 20, but generator 2 is supplying 15. So from where the rest 5 will come? So the rest 5 will come from here. Okay. So generator 1, it will transmit 5, the units are not given, so 5 watt, megawatt, whatever you can consider, 5 megawatts of power from generator 1 will be transmitted towards generator 2. Yes or no? The requirement of the load is 20, generator 2 can only supply 15, so rest 5 from where it will come? It will come from generator 1. Okay. So one thing is very sure, how much power is transferred through the transmission line? 5 megawatt. Okay. Now, so we know that the power transferred through transmission line is how much? 5 megawatt. So write this, power transferred through transmission line. So power transferred through transmission line is 5. Okay. And what is the formula of it? The formula is EV upon X sin del. Okay. In which if you see, you will term it E, you will term it V. So both are 1. Okay. So 1 into 1 upon the reactance is 0.1 sin del. When you will solve it for del, you will get the value of del which will be 30 degree. So just see, whatever has been given to us, through the data we have very quickly we have determined what will be the value of del and what is exactly happening here, isn't it? We have determined that. Now, at this end, if we call the reactive power as Qs, and at this end if we call the reactive power to be Qr, okay. So how much is the Qs that generator 1 is sending, and how much Qr the generator 2 is receiving, okay. If we have to find out that, how we will calculate that? So if suppose we have to calculate Q of S, what is the formula? It will be Vs square upon XL minus Vs Vr over XL and cos of del, okay. Now put the values here. So what you will get? 1 square, okay. If we call this Vs and we will call this Vr, so 1 square upon XL is 0.1 minus 1 into 1 upon 0.1 cos of 30. So you will get 1.34 per unit of power, okay. So how much is the value of Qs? The value of Qs is 1.34 per unit. This is what generator 1 is sending to the line, okay. Now after that, how much is Qr that is received by generator 2? So that we will calculate using the formula Vs Vr over XL cos del minus Vr square over XL. Now put the values. 1 into 1 upon 0.1 cos 30 minus 1 square upon 0.1, and you will get minus 1.34, okay. Why minus 1.34? Both the equations are same. So if we have obtained 1.34 there, it will be minus 1.34 as per looking into the equations, isn't it? So we have determined what is Qr and what is Qs. So Qs is being sent by generator 1, Qr is being received by the generator 2, okay, at this end. So the difference between the sent power and the received power, which will be the lost power, okay. So if I have to calculate how much is the power lost, so if I have to calculate the Q loss, so Q loss simply will be Qs minus Qr, okay. So if you will put the values, how much you will get? 2.68 per unit, okay. See how easily we have determined that, isn't it? So 2.68 is there in which option? 2.68 is in option A, is in option C, okay. So that means I think A, yeah, option A is having and option C is having. So B and D cannot be the answer, okay. So we have obtained Q loss. Now we have to determine Qg1 and Qg2. Now just see at this end. So at this end what we are having? At this end if you see, Qs is at this end if you see, we have Qg1, we have Qs, and we have this power which is taken by the load as well, okay, the load as well. Is that clear? We have Qg1, which is the generator is supplying, okay, and out of which what the load is taking and how much power we are transferring into the line, that all is given to us, okay. So if we simply apply the power balance equation, we will get the rest of the things, okay. So just see, what am I saying is, at bus 1 you will get Qg1, this is equals to Q of load plus Q of S, yes or no? Qg1 supplied by the generator will be Q of S transferred to the line plus transferred to the load, yes or no? Now we have the values. Q load is what? Q load is taking 5 here. So Q load is 5 and Qs you have calculated is 1.34. So what you will get? You will get 6.34 per unit. So this is how you have determined Qg1 at bus 1. Now similarly at bus 2. At bus 2, what is happening at bus 2? Generator 2 is sending Qg2, out of which some part is being sent to the load and some part will be transferred to the line. Yes or no? Some part will be transferred to the line. So we will be having Qg2 equals to Q of load plus Q of R. Yes or no? But if you see Q of R, it is not flowing from the generator. As per the direction we have taken, it is coming to the generator. So what we can do, if we will be putting the value here, what we will put, or before that I will write Q of load plus Q of R will be minus of QR because of the direction of it. Okay. So we will be getting Q of load minus Q of R. Now how much is Q load? It is 10. So 10 minus 1.34, which is the value of QR, you will get 11.34 per unit of power. So now see, Qg1 is 6.34. Okay. Qg1 is 6.34, Qg2 is 11.34, and Q loss is 2.62 per unit. That means C is the correct answer. So this is how we can solve this question. What am I doing? I am not doing any rocket science here. I am just going with the flow of the problem. This diagram is given to me. I am just looking towards the power flow, and whatever is the condition I am determining, I am using the formula regarding those, and everything is in front of you. Okay. So first I will see how much is the requirement of the load at generator 2, how much is the generator 2 is providing. Okay. Then where else the 5 megawatt is going, it is being transferred to the line. We applied this equation, we got the value of del. Then how much is the power, reactive power transferred from generator 1 to the line, how much is the reactive power received by at the generator 2 end. Okay, that we have calculated using the formula. Then they have to be same if there is no loss, but if there is loss, that means this is the difference of what is sent and what is received. We got the equation of loss. Then we applied the power balance equation, and we have obtained the value of Qg1 and Qg2. So this is how you can solve this question very easily. Okay, I hope it is clear to you. So this just applying the power balance equation, we have obtained the value of Qg1 and Qg2. I hope it is clear to everyone. Okay. Now moving towards the next question. So this is all about power system. Now we are into power electronics. So just see this question. 4 power semiconductor devices are shown in the figure along with their relevant terminal. We have thyristor, triac, GTO and MOSFET. But one difference is there. Current is flowing in opposite direction. Means currents are negative everywhere. Now the devices or device that can carry the current continuously in the direction shown when gated appropriately, means they are asking for which of these can carry current in the negative direction. Okay, which of these devices can carry current in this direction, means negative direction. So if we talk about the SCR or GTO, okay, so if we talk about SCR or we talk about GTO, what is the switch realization of SCR and GTO? So SCR and GTO, their switch realization is like this. They can carry both type of voltages, but they will carry only current in the positive direction. So this cannot be the answer, isn't it? Triac and GTO, they cannot carry current in the negative direction. Fine. So we have SCR thyristor and GTO, which cannot be an answer. They cannot carry current in negative direction. Next switch that we have is triac. So let's talk about triac. Now triac has a switch realization like this. Triac has a switch realization like this. Okay, it can block both type of voltage, it can carry both type of current, so it will support the negative current. So this can be the answer. Okay, then we have MOSFET. So this is a possible answer. Then we have MOSFET. So if we talk about MOSFET, what is the switch realization of MOSFET? So switch realization of MOSFET is like this. It can block positive voltage, but it can carry current in both the direction, and it is also carrying the negative current. Okay, so this is a possible answer for us. So triac and MOSFET, they can carry current in negative direction as well. So the answer will be triac and MOSFET, that is option B. Okay, that is there in the option B, so it will be the correct answer. So we have to comment here which switch can carry current in negative direction. Okay, so this is how you could have solved this question as well. Now moving towards the next question. This is from semi-converter. The waveform of the current drawn by a semi-converter from a sinusoidal AC voltage source is shown in the figure. If I naught is 20 ampere, the RMS value of fundamental component of the current will be what? There are two possible ways to solve this question. One is, if you force yourself to remember the Fourier series expression of semi-converter, or the other way is, if you know how to write the Fourier series expression of a quasi-square wave. Okay, so if you have a quasi-square wave, of this kind, okay, where this is the angle theta, okay, and this gap that we have is equal, okay, and this magnitude, if it is I naught, okay, let us suppose this is my source current. So what will be the Fourier series expression? So the Fourier series expression for this kind of waveform will be summation n equals to 135 to infinite 4 I naught over n pi cos of n theta sin n omega t. Okay. Now if I find out what will be the fundamental RMS value of this expression, then n will be where 1, and I have to divide by root 2 cos of theta. Okay. Now if you look into this waveform, this is not a perfect quasi-square wave. Yes or no? Because in perfect quasi-square wave, just see here, there is a perfect gap available here, but this waveform, it is ending on 180. So this is not a perfect quasi-square wave. But if we shift this waveform by 15 degree towards the left side, now this will become a perfect quasi-square wave because it is shifted 15 degree towards the left. So there will be a 15 degree difference here, 15 degree difference before 180 as well. So now it will become a perfect quasi-square wave. So if you will do that, your theta will become what? Your theta, you are making it to be equals to 15, and here you are making it to be equals to how much? 165. If you are shifting this waveform towards the left. So what is the value of theta you have? 15. What is I naught? It is 20. So when you will put the values, you have your answer 17.13 ampere. That will be the value of current. Okay, that will be the value of current that you will be having, 17.3 ampere. Okay, so just see. If you force yourself to remember the expression of semi-converter, so if you will become successful, you can solve this question. Otherwise, you don't have to. What kind of shape it is having? Quasi-square wave. For a quasi-square wave of this kind, this is the Fourier series expression. Okay, we require the value of theta. Theta we cannot find out from here. Theta is not 30. Okay, because this is right now not a perfect quasi-square wave. We have to shift it towards 15 degree. Then this proper gapping will be maintained, and it will be a perfect quasi-square wave then. Okay, so when we have shifted by an angle 15, it becomes a quasi-square wave. So what will be the value of theta after shifting? 15 degree. This is how you could have answered this question. Okay, I hope this is clear to you. From the expression also we are getting the same thing. Now see this question. The figure shows two buck converters connected in parallel. The common input DC voltage for the converter has a value of 100 volt. So Vs is 100 volt. Let me write that. Vs is 100 volt. The load resistance is 1 ohm. R is given 1 ohm. The capacitor has negligible ripple. Both converters operate in continuous conduction mode. So we have two converter. This is converter 1, this is converter 2. They are connected in back to back manner. Okay, they are connected in parallel to each other. They are connected in parallel to each other. The load resistance is given. The switching frequency is 1 kilohertz. Okay, so F is given 1 kilohertz, and the switching cycle is also given. So you can see switch S1 or converter S1 is operated for 0.5 millisecond, and then it is resting, then other converter is operating. Okay, so what is the duty cycle from looking into the waveform? The duty cycle will be 0.5 upon 1, that is 0.5. So this is how we can calculate the duty cycle looking into the waveform. The circuit operates in the steady state assuming that the converters share the load equally. The average value of IS1. What will be the average value of IS1? What will be the current carried by these converters? Source current carried by this converter. So they are identical converter connected in parallel. So what will be the source current carried by them? So if we have to calculate I of S1 or if we have to calculate I of S2, they both will be IS by 2, isn't it? If we calculate IS will be divided in both the converter because the converters are connected in parallel. Okay, so means we have to calculate the value of source current. How to find the value of source current? What kind of converters we are having? Buck converter. Okay, so for a buck converter, source current, okay, in a buck converter, whenever you have to find the source current, if you don't remember the formula, you can apply this trick. Power input is equals to power output. So Vs Is is equals to V naught I naught. From here you will get the value of Is, which will be V naught upon Vs into I naught. Okay. Now in buck converter, you know the formula that V naught is equals to D times Vs. Okay. So put here. So what you will get? D times I naught. Okay. You will get D times I naught. So Is is basically D times I naught. Now D is known to us, but we don't know the value of I naught. So we have to calculate the value of I naught. So I naught you can write V naught by R, and V naught you can write dVs. So it will become D square Vs over R. Now D is known to us 0.5. Okay, Vs is 100, R is how much? 1 ohm. So you will get 25 ampere here, and then coming back here 25 by 2. This will be 12.5 ampere. This is how you could have solved this question very easily. Okay. Now most of the students, they just left this question by looking into the language of the question and the diagram. Okay, they just got fear of this question. But if you will just go with the flow of the question, you will identify the areas how to find the solution of this question. Okay, so two converters, buck converter, they are connected in parallel. What is the problem in that? If they are connected in parallel, the current will divide. So ultimately we have to find the source current of buck converter and then divide it. Okay, so this is what we have done, and we have solved this question very easily, and you could have obtained 2 marks if you are giving 2018 paper. Okay, so this is how to solve this question. Now moving towards this question, this is the only question that we have from last 15 years from discontinuous conduction mode. Okay, just see, a DC to DC converter shown in the figure is charging a battery bank B2 whose voltage is constant at 150 volt. So B1 is charging B2 whose voltage is constant at 150 volt. So this is also the output voltage for us. Okay, this is the output side for us. B1 is another battery bank whose voltage is constant at 50 volt. The value of inductor L is 5 millihenry and the ideal switch S is operated with a switching frequency of 5 kilohertz. So F is given to us. Duty ratio is 0.4, D is also given to us. Once the circuit has attained steady state, and assuming the diode D to be ideal, the power transferred from B1 to B2 will be what? Okay, so just see. Inductor is present at the input side. So whenever the inductor is present at the input side, this is a boost converter, isn't it? In one video I told you already about this. If the inductor is at the output side, it will be a buck converter. If it is at the input side, it will be a boost converter. If it is in the middle of them, it will be a buck boost converter. Okay, so this is a boost converter. So for a boost converter, the output voltage is Vs over 1 minus D. How much is Vs? 50. This will be your input side, so it will be 50. 50 upon 1 minus D is 0.4. Okay, so how much you will get? You will get around 83.33 volt. Okay, but the output voltage as per the circuit has to be maintained at 150 volt. So V naught that you have obtained is less than the required value, that means we are having discontinuous conduction. Okay, we are having discontinuous conduction. So if we are having discontinuous conduction, what will be the plot of the current? So for a discontinuous conduction, the plot of the current will be like this. Just see, this is the on time. So since it is a discontinuous conduction mode, current will be reaching from 0 to a certain maximum value. So this will be our I max. Okay, this will be my current I max. Let me plot it again. Just see, current will be reaching from 0 to certain maximum value, then from maximum value to 0 value. Okay, and there will not be any current for certain period of time because it is a discontinuous conduction mode. Okay, so this is the on time in which current is reaching from 0 to maximum value. Okay, then from maximum to 0 value. Let me call this to be beta t. Okay, now under certain condition of discontinuous conduction mode, you know the output voltage. The output voltage is given by this expression. V naught is beta over beta minus d times Vs. So V naught has to be 150 into beta upon beta minus d is 0.4 and Vs is 50. When you will solve this equation, you will get the value of beta. Okay, when you will solve this equation, you will get the value of beta, and the beta value will be 0.6. Okay, just see what we have done. First of all, we have identified that this is the boost converter and output voltage has to be 150 volt. But the output voltage that we are getting, assuming continuous conduction, is less than the required value, so it is a discontinuous conduction mode. If it is a discontinuous conduction mode, this is how the inductor current will be varying. Okay, so this is the variation of inductor current from which you can find out the value of V naught, which is beta upon beta minus dVs. This is a popular expression for it. Okay, so we got the value of beta, which is 0.6 here. Fine. Now just what we have to calculate, how much is the power transferred from B1 to B2. Now when B1 will be transferring power, when there will be an on period, when the switch is on, at that time B1 is connected to L1 and S1. So this will be the circuit. It is not connected to that part of circuit. During the off time, it is connected to the load circuit. So it will transfer the power from this duration. Okay, from beta, from dt to beta, B1 transfer power to B2. Transfer power to B2. Is that clear? Okay. Now, so what is happening during the on period? During T on equals to dt. So during T on equals to dt, the switch will be on, and at that time we will be having source voltage exactly equals to the inductor voltage. Okay, source voltage is Vs and inductor voltage, it will be L di by dt. So how much is the current is changing? From 0 to I max, so it will be I max, and time it will be T on. Okay, so from here what will be the value of I max? It will be 50 into T on divided by L. Okay, now 50 into T on might be written as d of T upon L, and T might be written as 1 upon F. Now put the value. 50 into d is 0.4, F. How much is F given? 5 kilohertz, and L is 5 millihenry. So 5 kilohertz into 5 millihenry. How much you will get? This will get cancelled. You will get 0.8 ampere as value of I max. Okay, the value of I max we have obtained 0.8 ampere. Okay, now we have also calculated that the power transfer from B1 to B2 that we have to calculate will be at the duration of dt to beta t. Okay, will be at the duration of dt to dt to beta t. So what will be the current during this period? We have to find the area of this. Okay, we have to find this area, and from dt to beta t, okay, the energy transferred from B1 to BT, if we have to calculate, then this energy will be what? Energy, if you have to calculate, it will be what? Just tell me. If you have to calculate the energy, okay, then what will be the energy transferred? What will be the energy transferred? That you can simply calculate V naught into the area under the current curve, okay. That you can calculate simply by V naught into the area under current curve. Or let me do one thing, what I can do, I can directly calculate the power. Instead of calculating the energy, I can directly calculate the power here, okay. From D2 to BT, power transferred from B1 to B2, that will be energy divided by time. And what will be the energy? Energy will be V naught into area under current curve. Alright, okay, area under current curve divided by the time, okay. So what will be the area under the current curve? It will be half of I max into d minus beta t, isn't it? So we will write it V naught into half of B minus d times t into I max divided by t, okay. So t and t will get cancelled and you will get half of V naught into I max into beta minus d. Now what is the value of V naught? 150 we desire to have. I max you have calculated, which is 0.8 into beta minus d will be 0.6 minus 0.4. So what we will be getting? On solving this, you will get 12 watt as answer. Okay, on solving it, you will get 12 watt as answer. So this is how we have to deal with this question. Is that correct? We will get 0.2 and 2, which will be 0.1. Okay. Yes, it is correct. 12 of watt we will get as an answer. So did you get how we have solved this question? We have to calculate the power transferred from B1 to B2. So when exactly B1 will be transferring power from B1 to B2? When it is connected to B2. It will get connected to B2 during the dt to bt time, isn't it? So this is what we have recognized, that it is a discontinuous conduction mode. Then we have recognized when will be the power transfer taking place, and then we have calculated the power, okay. So this is how you have to approach for this question. This is from last 15-20 years. This is the first question that we have from discontinuous conduction mode. Otherwise otherwise there has always been a question from continuous mode, okay. And I am sure in 2024 also you will get a question from 1 or 2 question from continuous mode only, okay. But be prepared, if there is a question you will be able to solve. Now this is the last question that we have. A 3-phase controlled single phase rectifier supplied by an AC source feeds power to an RLE load as shown in the figure. So we have a figure for it. I think it is missing here. Let me draw it. So we have a figure for it. We have a source, okay, and we have a rectifier circuit. This is the rectifier circuit, and it is feeding a load of RLE type. Okay, where this E is 80 volt, and we have the value of L as 2 Henry. The value of resistance is 2 ohm. The value of L is basically 10 millihenry, okay. And this is the output port where we are getting the output voltage. Okay, so this is exactly the circuit is. Now what has been given to us is phase control single phase bridge rectifier supplied by an AC source feeds power to an RLE load as shown in the figure. The rectifier output voltage has an average value given by V naught equals to Vm by 2 pi 3 plus cos alpha. For this circuit, for this condition, they have calculated average output voltage for certain value of alpha and they have found that this is the value, where Vm is 80 pi and alpha is the firing angle. If the power delivered to the lossless battery is 1600 watt, then what will be the value of alpha is what we have to calculate. Okay, what has been given? Power transfer to the battery. The power transfer to the battery, so there will be an involvement of average value only. Okay, so the power transfer to the battery will be E naught into I naught. Okay, and this is given 1600 watts. So what will be I naught? 1600 divided by E naught. And what is the value of E? It is 80. So we will get 20 ampere at the average current. So from the given data, we can quickly calculate the value of current. Okay. Now V naught is also given. If we apply the KVL at the load side, V naught will be equals to E plus I naught R, isn't it? Now how much is the V naught? It is Vm by 2 pi 3 plus cos alpha 80 plus 20 into 2. Now Vm is given 80 pi upon 2 pi 3 plus cos alpha plus 80 plus 40 will be 120. Okay. Now this will give you 4 and from here you will get cos alpha equals to 0, that is alpha equals to 90 and that will be the answer. So you got your answer. Okay. So what I am doing? I am not doing anything else. I am just going with the flow of problem. They have given the power delivered to the battery. I use the formula of power delivered to battery. I got the current. Then they have given the average output voltage. I just applied the KVL at the output. This will be the equation. Average output voltage is given. I equated. I got the value of alpha. So there is not a rocket science. You don't have to be feared about the question. Just go with the flow of the question and you will get how you could have solved this question easily. So this is all about 2018. Okay. So did you like the teaching and learning methodology? Okay. If you want to experience the same kind of teaching and learning methodologies, join our live and online program. Okay, which is having 800 plus hours of live online interaction. Okay, we have some very good materials like theory book, exercise book having 4000 questions, GQB having all the PYQs available. Okay, and we have 130 plus online test which includes subject test, chapter test, multi-subject test, advanced subject test and AIMTS which has 3000 questions. So together you will be getting 7000 questions. If you will solve all those questions and get the right kind of learning, nobody can stop you becoming a GATE topper. GATE preparation is a very long journey. Okay, so if you need a strategy, if you need personal guidance, we have 12 personalized one-to-one mentorship session. You can interact with us and you can strategize your preparation. Okay, if you are really interested, you can call on this number and you can book a free counseling session. And also you can join our Telegram channel through the link given in the description box or through this link. Okay, both are same. And this is free of cost, in which you will get the regular updates about YouTube activities that we are going to take. You will get the lecture notes as well right after the lecture. You will get interesting questions along with the solution. You will get this important webinar, seminar and career guidance link as well. Okay, and the information regarding them and the PSU and government job notifications, so that you can make yourself updated in this arena. Okay, so join our Telegram channel. It is absolutely free of cost and get the updates and get the flavor of GATE preparation as well. So this is all about today's lecture. Okay, now this is we will meet next and we will discuss something else. Okay, soon we are having the GATE score booster series which is going to be started on 25th of this November. So you will see interesting question, you will see some probable question, and if you solve all those questions, if you will be the part of that activity, you are going to be the most benefited in the upcoming GATE exam. Okay, so be ready for that as well. Thank you so much for attending this session. Thank you.